Hello students, welcome to the course of our transonic testing technology. The main content of this course is performance test experiment of our transonic angle probe. In this experiment, three important parameters of inclined probe are tested: leading edge length 10, K value, and acoustic axis deflection angle zeta. The leading edge length refers to the distance from the incident point of the ultrasonic angle probe to the front end of the probe. This incident point refers to the position where the ultrasonic sound beam is emitted from the probe surface. When the probe contacts the workpiece surface, the ultrasonic wave will be refracted into the workpiece from its point. The K value of the ultrasonic probe refers to the refraction angle when the ultrasonic wave enters the tested workpiece beta. The tangent of that is the tangent beta as shown in the figure. But the sound axis deflection angle zeta is mainly used to describe the duration degree between the actual main sound beam of the probe and its theoretical geometric center axis as shown in the figure. All the above parameters have important influence on deflect location in ultrasonic testing. Therefore, it needs to be measured before ultrasonic testing. CTS-22A ultrasonic flow detector is used in this experiment, and the test block is CSK-1A. First, test the leading edge length of the angle probe 10. Place the CSK-1A test block vertically, apply the approximate amount of the couplant and testing surface, and then place the angle probe at the center of the two concentric arcs R50 and R100 with the front end of the probe facing the arc side. At this time, the initial wave T, R50 arc reflected wave, hereinafter referred to as R50, and R100 arc reflected wave, hereinafter referred to as R100, will appear on the oscilloscope screen of the instrument. Move the probe slowly in a short distance around the length direction of the test block, and we will find that the wave heights of R50 and R100 will fluctuate and rise or fall at the same time. This is because the ultrasonic sound beam is incident at different locations on the arc surface. Different reflectivities will be obtained. When the number of reflect beams increases, the echo height will increase. On the contrary, the echo height will decrease. Since the two circular arcs belong to concentric circles, their change rules are basically the same. When the probe moves to the maximum amplitude of R50 and R100, stopping moving the probe, press the probe with one hand under constant pressure and measure the edge from the front end of the probe to R100 arc with the other hand, which is recorded as M. It should be noted that when the amplitude of R50 and R100 reaches the maximum, it means that the ultrasonic beam is perpendicular to the circular arc at this time, and we know that any straight line perpendicular to the circular arc must pass through the center of the circle. So at this time, the probe incidence point just coincides with the center of the circular arc, and the length of the front edge of the probe plus m is just equal to the large arc radius of 100 millimeters. Therefore, the leading edge length of the angle probe should be 10 is equals to 100 minus m in millimeters. Next, test the k-value of the probe. It should be noted that there are two cases when measuring the k-value. When the k-value of the angle press is large, place the probe on the upper surface of the test block as shown in the figure, facing the test block 50 arc emission ultrasonic testing. When the angle probe k-value is small, the bottom of the test blocks shall be placed underward to conduct the test in the same way. This is because when the probe k-value is small, measuring the k-value on the upper surface of the test block will make the ultrasonic sound path too short, which will result in inaccurate measurement in the near-field area. Placing the probe on the bottom of the test block will effectively extend the ultrasonic sound path and avoid testing in the near-field area. The specific method for measuring the k-value is similar to that for measuring the leading edge length. It is necessary to slowly move the probe left and right in the length direction of the test block until the gamma 50 arc reflected wave reaches its highest. That is to make the ultrasonic beam perpendicular to plus 50 arc reflector up. Use a steel ruler to measure the distance from the front end of the probe to the edge of the test block and record it as large L. In the red triangle as shown in the figure, there are the following triangle relations. K is equal to tangent beta is equal to open parenthesis L plus 10 minus 35 close parenthesis slash 30. That is the wave of K. It should be noted that since the height of the test block is 100 millimeters, when the probe K value is small and the K value is measured at the bottom of the test block, the denominator in the formula should be 70. Finally, the measurement method of the sound beam deflection of angle of the angle probe is to place the test block horizontally, make the probe aim at the edge of the test block to radiate a ultrasonic wave. First, move the probe forward and backward to find the position of the highest reflected wave. When the edge echo is at its highest, then turn the probe until the highest reflection position is found, and finally fix the probe at the position of the highest reflected wave. The angle between the parallel line of the probe side and the edge normal theta is the sound axle reflection angle. The measurement and the calculation method is to use the steel rulers close to the side of a probe and read the scale difference between the steel ruler and two parallel edges of the test block, which is the length of the bevel of the red triangle shown in the figure. Zeta, the length of the other adjacent side of the corner, is the width of the test block, which is 100 millimeters, calculated by a cosine function zeta, the size of the corner. Note, as shown in the figure, the calculation zeta, when k value is greater than 1, the measurement is carried out by direct ultrasound. When the k value is less than or equal to 1 due to the short sound path of the direct sound wave, measurements are often carried out in the near-field region and the test error is large. Therefore, a single reflected sound wave is required for measurement. Well, performance test of the inclined probe is over. See you again.